you. All right, so we're talking about graphing linear equations. There's, well, what we talked about, there's three ways that we talked about graphing these linear equations. If I have 5x minus 4y equals 40. And the call there is just to graph such a thing. Well, yeah, and if it doesn't say how to graph it, that's perfectly fine. Do it whichever way you want. We talked about tables, graphing it with tables. We talked about using the x and y intercept, and then the slope-intercept form. So we could use any of those three that we wanted. However, let's go through maybe an example of each. Yeah, if I want to graph this using the intercepts, and there will probably be somewhere on the test where it actually says find the intercept, so this is good in that regard too. So yeah, if I want to find the intercepts to get to the graph here, yeah, the intercepts are always useful, helpful points to find, so knowing how to find those is good. How do we find an x-intercept? Well, if it's easy to remember, it's just set the other one to 0, right? If you want to find the x-intercept, you set y to be 0. And then solve for the x. So that's 5x minus 4 times 0 equals 40. Well, this is nice because that 4 times 0 is 0, so this is just 5x equals 40. All we have to do is divide by 5. We got x is 8. And then, of course, note there that the x is 8. That's in the ordered pair, right? The x is 8, and the y, well, the y we set to be 0, so it's 8, 0 is the x-intercept. And then, of course, for the y-intercept, we do just the reverse. On the y-intercept, the x is 0, so we set x to be 0. And solve that for the y value. And that's going to be along about divided by -4, so y is -10. Sound about right? So the ordered pair there for the y-intercept would be 0, -10. The x is 0, the y is -10. And yeah, since we know this is a linear equation, our graph is a line, and 2 points do determine a line, right? So this is enough. So we go to 8, 0. And 0, -10. And there's our 2 points, enough to graph this line. Okay? All right, so that's one way of doing it. Graphing lines. Another, what if I have y equals, -3x minus 7. I want to graph, again, just want to graph it. Well, this one is probably set up for another method, right? This one is in what form? It's in slope-intercept form. Also, sometimes we term it y equals mx plus b form. Yeah, it's got the y equals format there. And so recognizing that, well, we've got m is -3, and we've got b there is -7, right? What does that tell me? Two things. The m is the slope. And the b is, well, that's the y-intercept. And so this here is enough to go graph that, isn't it? So to go to the y-intercept, -7. It's right there. So there's the y-intercept. And the slope being -3, well, could say that's over 1, couldn't we? And so we have rise over run. The rise is -3, the run is +1. One way you could go with that. So a rise of -3, well, that would be down 3. 1, 2, 3. But then we run 1, so that puts me right there. That point would be -10 and 1. But that's, again, 2 points. So I've got my little graph there of my line. Okay? Kind of on a related note to that, what kind of tying the two forms, you know, the other form, this, let's just do this one. 6x minus 3y equals 11. That's the other form that we talked about, that's standard form. And on a related note there, what if I wanted that, from that form, what if I wanted to determine the slope right there? Well, there's a couple ways I could do that, but probably the easiest way, I would say anyway, would be to change it to the other form, change it to the slope-intercept form. And I would do that by getting the y on a side by itself. So move it around, change things up, and get the y term on a side by itself. So we subtract 6x, subtract that term, so it'll be minus 3y equals, I'm going to say, -6 plus 6x plus 11, because I can't combine those terms. Then divide off the -3, and that would, of course, divide both of those by -3, the -6x and the 11. Negative divided by negative is a positive, so that's 2x. That would be a -11/3, one way you could write it. Yeah, so that's, there's my slope, right? Okay. All right. Yeah, if those... all else fails, I guess, there's always, when you're graphing any equation, not just for these linear, there's always the possibility that you use a table. What if I had 2x plus y equals -12. And I wanted to complete a table. Let's say x, let's go with 1 and -2, and then the y, make it 5. Okay? The y is 5. Yeah. I mean, you can always draw up a table or complete a table and help you out on the graph there. So what does this mean? Well, this means I want x to be 1. And so that sets up a fairly nice little equation. 2 plus y equals -12. Subtract the 2, and that gives me -14 for the y. X is -2. Well, plug in x to be -2. So -4 plus y equals -12. So add the 4, and that gets me y equals -8. Does that sound okay? And then last but not least, the y here being 5. What is that going to do? We've got 2x plus 5 equals -12. Yeah, in that case, I'd plug in the y to be 5. So there I'd subtract 5 first, and then divide by 2. So x is negative 17 halves, or you could say negative 8.5 for the x. And so that would give us enough to go on to graph that thing. 1 and negative 14. Negative 2 and negative 8. And negative 8.5 and 5. Yeah, so those do seem to be lining up there like they should. Okay?